You were born on a specific day. Maybe it was a Tuesday. Maybe it was raining. Your parents remember it. And every year you celebrate that moment when you came into existence. But here is something that will rearrange everything you think you know about yourself. The atoms that make up your body right now. The hydrogen in your blood, the oxygen you are breathing, the calcium in your bones. Most of them are older than the sun. Not a little older, not a few million years older. We are talking billions of years older than the star that gives us light and life. In fact, most of the hydrogen atoms inside you right now are approximately 3 times older than our entire planet. Stop. 90. Think about that for a moment. You are not stardust. That poetic phrase you have heard 1,000 times is actually incomplete. The truth is far more ancient and far more strange. You are made of material that existed before any star ever burned, before the first galaxy spiraled into existence. What you do to me? Before light itself could travel freely through the cosmos. Richard Feynman, perhaps the greatest physics teacher who ever lived, understood something profound about this. He once said that if you could somehow see the world as a physicist sees it, you would realize that you are looking at a universe far more magnificent, far more intricate, and far more connected than any poem or painting could ever capture. Today, we are going to see the universe that way, and you will never look at your own hand the same way again. Let us start with a simple question that turns out to be anything but simple. How old are you? Now, the obvious answer is whatever number of years has passed since your birthday. Maybe you are 25. Maybe you are 50. Maybe you are 16 and watching this because physics suddenly became interesting. But that answer only tells us how long ago your body was assembled into its current configuration. It tells us nothing about the age of the materials that body is made from. Think of it this way. I know. Imagine someone builds a house in 2024 using bricks that were manufactured in 1950. How old is the house? Well, the structure is new, but the bricks themselves have existed for 74 years. The house has 2 ages simultaneously, and both of them are true. Your body works the same way. You have a birthday that marks when you were assembled. But the atoms that compose you, the fundamental pieces that came together to form every cell and every thought, they have their own birthdays, and those birthdays are ancient beyond comprehension. Here is where it gets interesting. When astrophysicists actually calculate the real age of the atoms in a human body, they discover something remarkable. About 62% of the atoms inside you, the ones that constitute roughly 8% of your total mass, are hydrogen atoms. And those hydrogen atoms did not come from stars. They did not come from the sun. No, they came from the first few minutes after the beginning of everything. We are talking about the Big Bang itself. According to our most precise measurements, protons, which are the hearts of hydrogen atoms, appeared in the universe approximately 13.813 billion years ago. That number has a margin of error of about 38 million years, which sounds imprecise until you realize that scientists are confidently dating something that happened before matter as we know it even existed. The universe is currently estimated to be about 13.8 billion years old. Our planet formed about 4.54 billion years ago. Our sun ignited roughly 4.6 billion years ago. Do the math. The hydrogen atoms in your body are more than 9 billion years older than the sun. They have been waiting around since before our solar system was even a possibility, drifting through space, participating in cosmic clouds, watching galaxies form and die, until finally, they ended up here. In you, reading these words, thinking these thoughts. Gosh, and you thought turning 40 was a big deal. Now, to really understand why your atoms are so impossibly old, we need to take a journey back to the beginning. Not the beginning of Earth. No, not the beginning of the sun. The beginning of everything. Imagine the entire universe compressed into a space smaller than an atom. Everything that would ever exist. Every star, every planet, every person, every thought, all of it packed into an infinitely dense, infinitely hot point. This is not a metaphor. This is what physics tells us was the state of reality approximately 13.8 billion years ago. Then, something happened. We call it the Big Bang, though Feynman himself would probably object to that name because it was not an explosion in the conventional sense. There was no space for anything to explode into. Space itself was being created. Time itself was being born. In the first fraction of a second, something remarkable occurred. Between 1/1,000,000th and 1/1,000,000th of a second after the Big Bang, the universe had cooled enough for electrons to form. These are the tiny particles that orbit atomic nuclei and allow chemistry to happen. They are also what make electrical current flow and what allow you to see and think. The electrons in your body right now, the ones carrying signals through your neurons as you process these words, they have existed for nearly the entire history of the universe. They are among the oldest things in existence. But here is where it gets even stranger. From the first second of the universe through the first 3 minutes, something called nucleosynthesis occurred. The cosmos was like a giant nuclear reactor. And in that cosmic furnace, quarks combined to form protons and neutrons. Protons are positively charged particles that form the nuclei of atoms. A single proton by itself is the nucleus of a hydrogen atom. So within 3 minutes of the Big Bang, the universe had created the raw materials for hydrogen. Protons and electrons were flying around in a superheated plasma, too hot to combine into atoms, but already inexistent, already ancient by any human standard, though the universe itself was still an infant. Now, you might be thinking, if the protons and electrons existed so early, why did it take so long for actual hydrogen atoms to form? This is an excellent question, and the answer reveals something beautiful about how physics works. When protons and electrons are extremely hot, they have too much energy to stick together. It is like trying to connect two magnets when someone keeps shaking your hands violently. The attraction exists, but the chaos prevents the bond. The universe had to wait. It had to expand. It had to cool. For approximately 380,000 years after the Big Bang, the cosmos remained a hot, dense plasma. Light could not travel freely because photons kept bouncing off free electrons. The universe was essentially opaque, like being inside a fog so thick you cannot see your own hand. Then, around 380,000 years after creation, something magical happened. The temperature dropped enough for electrons to finally combine with protons. Hydrogen atoms formed. The fog lifted. Light could finally travel in straight lines. This moment is so important that we can still see its echo today. The cosmic microwave background radiation, that faint glow that fills all of space, is the leftover light from this exact moment. It is the oldest light in the universe, a snapshot of the cosmos when it was 380,000 years old. Every hydrogen atom in your body was born around this time. Give or take a few thousand years, every single one of them has been around for approximately 13.8 billion years. And here is the thing about hydrogen. It is the most abundant element in your body by atom count. More than 60% of the atoms inside you are hydrogen. Every water molecule you have ever drunk, every fat molecule, every carbohydrate, every strand of DNA, all of them contain hydrogen atoms that have existed since the universe was young. You are walking around with material from the dawn of time inside you, right now, as you breathe. But wait, you might say, what about the other atoms? What about the carbon that forms the backbone of every organic molecule? What about the oxygen we breathe? The calcium in our bones, the iron in our blood? Here is where the story becomes even more interesting, and where that famous phrase about stardust actually becomes relevant. Hydrogen and helium were the only elements produced in significant quantities during the Big Bang. The universe was expanding too fast and cooling too quickly for heavier elements to form. To make carbon, you need to smash 3 helium nuclei together at precisely the right moment. To make iron, you need even more complex nuclear reactions. These reactions require specific conditions. Extreme temperatures, extreme pressures, sustained over long periods. In other words, these reactions require stars. The first stars ignited roughly 100 to 200 million years after the Big Bang. They were giants, monsters of plasma and light, burning through their hydrogen fuel at incredible rates. And inside their cores, something wonderful was happening. Hydrogen was fusing into helium. Helium was fusing into carbon. Carbon was fusing into oxygen. For millions of years, these stellar furnaces cooked up heavier elements. Then, when the stars exhausted their fuel, they exploded in supernovae, scattering their newly forged elements across space. This is the stardust part. The carbon in your DNA, the nitrogen in your muscles, the phosphorus in your bones. These elements were created inside stars that lived and died before our sun was born. Some of those stars may have exploded 5 billion years ago. Some may have exploded 10 billion years ago. The material got recycled again and again through multiple generations of stars. So here is the complete picture. The hydrogen in your body is primordial, from the Big Bang itself, approximately 13.8 billion years old. The heavier elements like carbon, oxygen, and iron are somewhat younger, forged in stars that existed before our solar system, perhaps 5 to 10 billion years old. Even your youngest atoms are older than Earth. This is not poetry. This is physics. This is what the evidence tells us when we measure isotope ratios and calculate nuclear timescales. Every atom in your body has a history that stretches back billions of years before you were born. But here is where it gets really interesting. Richard Feynman, in addition to explaining quantum electrodynamics and winning the Nobel Prize and playing bongo drums at strip clubs, also thought deeply about how time works on cosmic scales, and he made a claim that went unquestioned for more than 50 years. In his famous lectures from the early 1960s, Feynman stated that the center of the Earth should be about a day or two younger than its surface. This sounds bizarre, but it makes sense when you understand general relativity. Einstein showed us that gravity affects time. The stronger the gravitational field, the slower time passes. Since gravity is stronger at Earth's center than at its surface, time should move more slowly down there. People quoted this for decades. It appeared in textbooks. Nobody checked the math. Then, in 2016, 3 Danish physicists actually did the calculation, and they discovered something remarkable. Feynman was wrong, but not in the direction you might expect. The center of the Earth is not a day or two younger than the surface. It is approximately 2.5 years younger. Feynman underestimated the effect by more than a factor of 300. And the Sun, the Danish team calculated that the center of the Sun is approximately 39,000 years younger than its surface. Stop and consider what this means. The nuclear furnace at the heart of our star, where hydrogen fuses into helium and produces the light that makes life possible, exists in a different temporal frame than the surface we see. Time itself flows differently depending on where you are relative to mass. This is not science fiction. This is measured, verified physics. GPS satellites have to account for relativistic time dilation to function correctly. Atomic clocks run at different rates depending on their altitude. The universe does not have a single universal clock, ticking away the seconds equally everywhere. And this connects back to our main story in a profound way. When we say that your atoms are 13.8 billion years old, we are measuring against cosmic time, the time measured by observers far from any significant gravitational well. But the atoms in your body have not experienced 13.8 billion years of time from their own perspective. They have traveled through regions of space with different gravitational fields, different velocities, different temporal flows. In a very real sense, asking how old an atom is becomes philosophically complicated. Old according to whom? Old according to what clock? This is the kind of question that would have delighted Feynman. He loved pointing out that the universe is more subtle than our intuitions suggest, that the simple questions often lead to the most profound answers. So where does this leave us? What does it mean to be made of ancient material? Here's one way to think about it. You are a temporary arrangement. The atoms in your body right now are not yours in any permanent sense. You are borrowing them. You will return them when you die, and they will go on to become part of something else, just as they were part of something else before you were born. Those hydrogen atoms in your blood plasma, before they were you, they might have been part of a comet. Before that, part of an interstellar gas cloud. Before that, part of a different solar system entirely, orbiting a star that no longer exists. And 13.8 billion years ago, there were free protons in a universe so hot that atoms could not form. After you die, those same atoms will participate in other processes. They might become part of a tree, part of another person, part of the ocean. Eventually, billions of years from now, they might find themselves inside another star, participating in fusion reactions, or drifting in the void between galaxies. You are not separate from the universe. You are the universe temporarily configured into a pattern that can think about itself. Feynman once said that the same thrill, the same awe and mystery, comes again and again when we look at any question deeply enough. The deeper we look, the more interesting it becomes. Consider this. Every time you drink a glass of water, you are consuming atoms that have been around since before the first star ignited. Every breath you take contains oxygen atoms that were forged in stellar cores billions of years ago, and scattered through space in violent explosions. You are not observing the cosmos from the outside. You are part of it. You are made from it. The distinction between you and the universe is, in a certain sense, an illusion created by the temporary arrangement of ancient atoms into a pattern that calls itself. This is not spirituality dressed up as science. This is simply what the physics tells us. We are made of material that participated in the earliest moments of cosmic history. We carry the Big Bang inside us, literally, in the form of hydrogen atoms that have persisted unchanged for billions of years. There is a tendency when discussing these ideas to make them feel small by over-familiarizing them. Everyone has heard that we are made of star stuff. The phrase has become a cliché, something printed on coffee mugs and inspirational posters. But clichés become clichés because they point to something true. And the truth they point to is staggering when you actually stop to feel it. You are ancient. Not metaphorically, literally. The majority of the atoms in your body are older than any mountain, older than any ocean, older than the sun that warms your face. They have existed for approximately 13.8 billion years. Patient and persistent, waiting through cosmic ages until they happen to come together in the particular configuration that is reading these words right now. Feynman understood that this kind of knowledge does not diminish wonder. It amplifies it. Knowing that a flower evolved through billions of years of natural selection does not make it less beautiful. Knowing that the hydrogen in your tears is older than the sun does not make your emotions less meaningful. If anything, it makes everything more meaningful, because it means that the universe, after 13.8 billion years of expansion and cooling and stellar evolution and planetary formation, finally produced something that could look back at itself and ask how old its atoms were. That something is you. The atoms do not care. They are not conscious. They do not wonder about their age. But arranged in the particular pattern that constitutes your brain, they become capable of wonder. They become capable of understanding their own history. They become capable of being amazed that they exist at all. This is what physics offers when we pursue it honestly. Not cold equations and sterile facts, but a kind of humility and awe that comes from recognizing our place in something vast and ancient and ongoing. Your atoms were here before you. They will be here after you. But right now, in this brief flicker of cosmic time, they are arranged in a way that can appreciate its own improbability. That seems worth knowing. That seems worth celebrating. The next time someone asks how old you are, you might tell them the truth. You are, depending on which atoms you choose to identify with, somewhere between 4.54 billion and 13.8 billion years old. You just took your current form relatively recently, and the universe, patient and creative, continues to rearrange itself into new patterns, new questions, new moments of temporary understanding. You are one of those moments. Make it count. End card. Subscribe moment.